Hello everyone, Miss Sinclair here. We're going to continue on with our exponential growth and decay. This video will be shorter than yesterday's. There's a few questions I want to do with you, and then I'm going to have you do a few on your own. So just as a refresher, we learned about exponential growth and we learned about exponential decay yesterday. These are important formulas. And normally if you were taking the Regents, I would say that you need to remember them, but you don't really need to remember them. Just be aware of what they are and know where to find them. In this homework, for example, you can always look back and find these formulas. So the formula for exponential growth and exponential decay are almost the same. The difference comes in with the multiplying factor, the part in the parentheses. It's either 1 plus r if it's growth. Remember, growth is greater than 1. And it's 1 minus r if it's decay. Remember, decay is less than 1. Otherwise, the formulas look exactly the same. So I want to take a look at the exit card from yesterday. Some of you did really great on it, and some of you I thought maybe could use a little me going over it, so I figured I would do that. So this says the function v of t 1350 1.017 represents the value in dollars of a comic book. The yearly rate of appreciation of the comic book. So appreciation is the opposite of depreciation. Appreciation means that the amount of money is going up. So this person bought a comic book and they were lucky because it was worth more as the years went on. So when I look at the multiplying factor, 1.017, I know that that's growth. And I know it's growth because 1.017 is greater than 1. So 1.017 must be equal to 1 plus r because it's exponential growth and it's the part in the parentheses. 1 plus r is in the parentheses for that formula. So 1.017 must be equal to 1 plus r. Well, let's just solve for r. Let's minus 1 from both sides. So I get 0.017 equals r. That is as a decimal. It's always as a decimal in these formulas. If I want to get it to be a percent, then I need to take that number and times it by 100 or move the decimal over 2 spots. So it becomes 1.7 as a percent, 1.7%. Okay, I want to do a few with you just as some practice. And then I'm going to, like I said, I'm going to leave you to do some on your own. So number 1, a bank is advertising that new customers can open a savings account with a 3.75% interest rate compounded annually. Okay, so remember when we talked about putting money into accounts and we talk about interest, that's always going to be exponential growth because the banks always give you interest on your money. They add money into your account. So we need the formula for exponential growth. And that formula is y equals a parenthesis 1 plus r to the t. Okay, 3.75% interest. Robert invests $3,000 into an account at this rate. If he makes no additional deposits or withdrawals on his account, find the amount of money he will have to the nearest cent after 4 years. Okay, so let's turn this 3.75%, let's turn it into a decimal. So to turn it into a decimal, we divide by 100 or move the decimal place over 2 spots, 0.0375. It's probably easier just to divide by 100 and see what you get, but if you wanted to, you could move the decimal over to the left 2 spots and then add any zeros as placeholders that are needed. We needed one right there. Okay, so do me a favor. Pause the video, plug in what you know, get an answer, and then come back. Okay, so we're going to plug in 3,000 in for A because that's his initial amount. 1 plus 0.0375, and then I want to raise that to however long it is. Well, it says 4 years. Okay, so let's put that into our calculator. Now I'm going to write out the whole number. And then I kind of ran out of room. Sorry about that. So I'm just going to erase this just so I have a little more room. And this is the correct answer, 3475.951245. But it does say to the nearest cent. And even if it didn't say to the nearest cent, since it's money, money's always to the nearest cent. We only want two places. So if we look at that 1, we see if it makes the 5 round up, and it doesn't. So it just rounds to 0.95. So y equals 3475.95. So Robert will have $3,475.95 after 4 years. That's pretty good. Okay. If a person takes a given dosage D of a particular medication, then the formula A equals D 0.08 to the T represents the concentration of medication in the bloodstream T hours later. If Charlotte takes 200 milligrams of the medication at 6 a.m., how much remains in her bloodstream at 10 a.m.? Okay, so they give us the formula. Sometimes you'll be given kind of a partial formula, and that's what they did here. We can tell that it's an exponential, and we could tell that because it's raised to an exponent. So the fact that it's raised to the t, that's like the big clue for us that this is going to be an exponential. This is an exponential graph, an exponential equation. Now it is a decay, and we know it's a decay because 0.8 is less than 1. And that makes sense in the context of the question, because when you take a medication, like if you take Tylenol, the amount in your bloodstream decreases over time. So 0.8 shows that it's decay. Now, they used different letters. They used A here where we usually use Y, and they used D where we usually use A. But everything still stays the same. This part right here, the D, is going to be the initial amount. So how much did Charlotte take initially? Charlotte took 200 milligrams. All right, and she took it at 6, and then we want to know what remains at 10. So let's think. So from 6 to 10, how much time has passed? Because that's what we need to know. From 6 a.m. to 10 a.m. We start at 6 a.m., we say 7 a.m. is 1 hour, 8 a.m., 2 hours, 9 a.m., 3 hours, 10 a.m., 4 hours. So T is 4 hours. So again, just pause for a minute, finish this problem up, and come back and I'll give you the answer. Okay, so A equals the amount that Charlotte took initially. We said that was 200. They told us 0.8. We didn't have to figure that out. And we decided that it was 4 hours later. So let's put that into our calculator. Charlotte has 81.92 milligrams of medication still. It makes sense that it's less because the amount of medication in your bloodstream goes down. So she started with 200 milligrams and now she only has 81.92. Okay. I want to do one more with you and then I'm going to leave you to do the rest on your own as homework. Bernice purchases a car that depreciates, loses value at a rate of 24% per year. So I'm going to need my exponential decay because it's depreciating. It's losing value. So y equals A, 1 minus r to the t. The initial cost of the car is $35,000. So we're going to put that in for A. The initial amount, 1 minus, now do not put 24. That's not right. We need to turn that 24% into a decimal. So the way we do that is 24% divided by 100 is 0.24. So we're going to put 0.24 in, raise that to the t, that's 5 years, and then we'll type this into our calculator. Okay, so, we don't even need to. Okay, so I didn't even look at my choices. So I got an answer of 8874.338816. But actually, we didn't even need to do that. They just want us to pick the right choice. So it looks like what they did was they did simplify this 1 minus 0.24. So let's just do that. 1 minus 0.24 is 0.76. So this equation can write it like this. We didn't need, not that the answer that we got is wrong of 8,874, but based on the choices, they didn't really want you to go that far. They just wanted you to kind of simplify the equation. So choice 3. Okay, I would like you to try the rest of these on your own. You have 3 word problems and 2 review from this unit. Okay, bye everyone.